My name's Jimmy Wriston. I'm Chief Engineer with the Department of Transportation. I've been doing this for about 14 years. And I'm going to show you today, basically, I'm going to go through the software, teach you how to use the software. I'm going to show you how to do this the same way that I go to the schools that I volunteer at. And to give you a little perspective on that, for the last 14 years, 78% of all the contestants that show up at the state finals, I have been their volunteer. So this method works. So that's almost 8 out of every 10 students that put a design into the competition that end up at the state finals are mine. So we'll start off. It's an iterative process. You know, there is no single silver bullet best design in the world in this software. And it's an iterative process. That means there's trade-offs. For example, if you're designing concrete, and some of you have had this concrete design. So if you're designing concrete, you manipulate the properties of the components of your concrete to where it might have more durability. Or you can manipulate them a different way and it maybe have more strength. But in order to get more strength, you give up a little durability. In order to get a little durability, you give up a little strength. So it's an iterative design process. But most design processes are exactly that. And it's a trade-off. So let's get started. The first sheet here is read the design requirements. And I'm not going to read to you today. If you have questions, just holler, but just follow along as we go. So we'll go to the next screen. This is the screen where you start the iterative process. You start making choices. And every choice you make will affect choices down the road. We're going to use a particular example today. No one particular example, but a specific example. We're going to put our bridge at 12 meters. That's where it sets the deck elevation of the bridge. Our next choice is the support configurations. We can choose standard abutments or arch abutments. If you choose the arch abutments, you also have the option of selecting the height. You can go from 12 meters all the way down to 4 meters. That sets the seat height of the abutment. We'll use standard abutments for our design today that we're going to build. You also have an option of pier for a 1-span bridge, or add the pier for a 2-span bridge. If you look down here at the site cost in the lower left-hand corner of the screen, every choice we made is adding dollars to the site cost. So we're going to end up with a certain amount of cost to start with. We chose, everyone's going to think that there's a sweet spot in the elevations, and it's just not true. If we had chose a bridge all the way at the top, the highest elevation that we could have, we would have ended up with the smallest excavation cost, but we would have ended up with more cost for the longer bridge. Dropping all the way down to the bottom would give us the most cost for elevation, for excavation, but it would have resulted in a shorter bridge. Somewhere in the middle may be a good place to go, somewhere at the top, somewhere at the bottom. With the iterative design process, and I call it the championship winning process because that's what it does. That's what kids that I teach how to do this do. They win championships, state championships and national championships. Today we're going to use the pier, and we could lower or raise the height of that pier. If you'll watch that cost in that lower right-hand corner, if you drop that pier height down to 0, that cost goes down, and we could later build up support from that concrete with steel members, or we can go ahead and bring our concrete pier on up, which we'll do today, on up to 12 meters, right up to our base of our deck. So we're going to be building a 2-span bridge today. The next option is we can have no cable anchorage, or we can have 2 cable anchorages. There is an option in some designs where you can have 1 cable anchorage, but not in this particular one. We'll not use the cable anchorages today. So we've made our choices on this, and we're at $126,100 for our site X so far. Next choice. You can have a medium-strength concrete deck that's a little bit thicker, or you can have a high-strength concrete deck that's a little bit thinner. That's kind of counterproductive, but it's higher-strength concrete. This is one of those choices that I was telling you about. We can work with either one. We can go with a thicker deck, cost a little more because we're going to use a little more material, or we can go with the higher strength material, which we also pay a premium for. Today we'll use the high strength concrete deck. The loading. This is one of the features in the software this year that's a little bit different. The basic loading is the standard AASHTO truck loading, 2 lanes. That's the standard loading, and then there's an option for permit loading. The permit loading is what's different in the software from previous years. Last year, the software, the axles were all the same weights for the permit truck. This year, the front axle is a little bit lighter. Now, whether or not that results in a more efficient design, we'll find out as we work through different designs, but we're going to use the standard loading today. There's also some templates within the software. You could select 2 simple spans, a deck truss. There's a continuous through truss. There's 2 simple span through truss. Every time that we chose, there's different templates that can go along with the different site-specific things that we've chosen up to this point. We can go along with that, or we can just build our own. And my partner here that's running the computer today likes to build her own. So we're going to choose none. We're not going to use a template today. So click Next. Here's the title block, and I always tell the students it was designed by. Always put your name in there. If you're proud of something, put your name in there. So type your name in there. You do good work, you want credit for it, right? The project ID, I always use this field. I use this to actually, when I save my designs, I use the design file name that I'm going to save it under right there for the project ID number. So we'll leave it blank today and move on. This is to basically tells you how to design the truss bridge, which I'm not going to read to you. I'm just going to talk to you. So let's just hit Next here. Actually, we're finished and we're ready to go.